natural logarithm f of x equals to ln x. So we already talked about common logarithm. So common logarithm is called log, right? And natural logarithm is ln x. So they both read log. So to distinguish the difference between common and natural, for common logarithm, I would just call that log. For natural logarithm, I would just call that ln. So this one, I would just call that ln of x. Okay, so the domain of ln of x is x greater than 0. So take a look at the graph. So the graph is very similar to the common logarithm, the log, but there is a minor difference. We will talk about that in a separate video. The shapes, they look the same, but if you graph both functions in the same graphing paper, you will see that there is a difference between those two curves, and the only identical thing is they have the same x-intercept at 1, 0. So this is an increasing function from left to right. The x-intercept is at 1, 0, and there is no horizontal asymptote, but there is one vertical asymptote, just like the log, at x equals to 0. So look at the vertical asymptote. So at x equals to 0, so as x approaches to 0 from the right, y goes all the way down. So y goes to negative infinity. So x equals to 0 is a vertical asymptote. So since I said that when x is equals to 0, we have an asymptote, that means ln of 0 is undefined. Do you see that? ln of 0 is undefined because x equals to 0 is a vertical asymptote. And then ln of positive is defined. ln of positive is not always positive. Take a look. When x is equals to 1, ln1 is equals to 0, right? So we can add this to it. So ln1 is equals to 0 because this is an x-intercept. And then when x is greater than 0, so this piece, when x is greater than 0, when x is greater than 1, so this piece, when x is greater than 1, the curve is greater than 0. So y is greater than 0. When x is between 0 and 1, y is less than 0. So ln positive is not always positive. You have to tell me what kind of x value. So when x is greater than 1, ln something greater than 1 is positive. When x is between 0 and 1, ln of that numbers, so let's say ln 0.5, so that is negative. When x is equals to 1, ln1 is equals to 0. That is the x-intercept. So ln positive is not always positive. ln positive is defined, but depending on the x value you pick, it can be positive or negative or 0. And ln of negative is undefined because there is no curve on the left hand side of the y-axis. So ln negative is undefined. And then let's take a look at how do we get the common logarithm. So for natural logarithm in red, do you see that we have y equals to log base e, so log base e of x. So for common logarithm, when the base is equals to e, so the entire piece log base e becomes an ln x. So ln x is called natural logarithm. So for example, if you have a common logarithm log base e of 10, so that is just ln 10. All right, so let's take a look at the ln positive, 0, and negative. So for the first one right here, so we have ln2, right? So the base is e, so ln2 on your calculator. So any calculator, so let's say the graphing calculator, there is an ln key on the left hand side of the 4. Do you see where the 4 is? On the left hand side, there is an ln key, right? So you hit ln and then you hit 2, you can close the parenthesis, and then once you hit enter, you will get this approximation. So ln2 is approximately equals to that. So this is in a logarithmic form. If you put this back to exponential form, you take the base e raised to that long power, then you will get your 2 back. And then what is e equals to? E is approximately equals to 2.718. So e is approximately equals to 2.718. So what about ln of 0? So I have an example right over here. So ln 0 is equals to what? So taking the base e, I am asking e raised to what power is equals to 0. So 2.7 or 2.718 raised to what power is equals to 0? How can that be possible? You take 2.7, you multiply itself a few times, you get a 0. How can that be possible, right? So therefore, this is impossible, and therefore, ln 0 is undefined. How about ln negative? So let's say ln negative 1, what is that equal to? So taking the base e raised to what power is equals to negative 1. So are you kidding me? 2.7 raised to what power is equals to 1? You take a positive value, you multiply itself a few times. Are you going to get a negative? No. Are you kidding me, right? So you can't get a negative. So that means this is impossible. So therefore, the conclusions are ln 0, undefined. ln negative, undefined, right? So for both common log and natural log, so log and ln, log of positive and log of log of positive and ln of positive, they are defined. Not always positive, they are defined. Okay, and then log of 0 and ln of 0, they are undefined. Log negative and ln negative, they are undefined. Okay, why do we need to study ln? Now, that brings you to the next question. What is the inverse function of e to the x? So e to the x looks like this, right? So e to the x, so e to the x, the graph of e to the x looks like this, right? It's an increasing function. Okay, what's the inverse function? So for inverse function, first we have to write y equals to e to the x. That is what we start with. And then to find an inverse function, you have to switch x and y, right? So this is x equals to e to the y. And then you have to do everything you can to isolate y on one side. But in order to bring the y down to the front, you have to ln both sides. So let me show you what do I mean by ln both sides. So ln both sides means you take ln x and then ln the other side. Is this true? Absolutely yes. So let's say 2 is equals to 2, right? ln 2, that is equals to ln 2. You can use your calculator to check it. ln 2 is equals to ln 2. ln 1 is equals to ln 1. ln 10 is equals to ln 10, right? So once you take ln on both sides, you can use a property of ln, which is what I will talk about in the next video. You can carry that to the front. And this is one of the main purpose of studying ln, is carry the power down. Write this down. One of the main purposes of studying ln is you want to carry the power down. This is a very powerful technique in higher level statistics, mathematics, when you take a business math class, when you take a mathematical modeling class. This technique is everywhere, right? Take ln and then bring the power down. This technique is so popular, it is almost everywhere. So you have ln x, and then this is y, and then times ln e. What is ln e equals to? So what is that equals to? So this is base e, right? So base e raised to the what power is equals to itself? The answer is that is equals to 1. So we have y times 1. Then this is ln x equals to y. So therefore, the y inverse, or put this in function, f inverse of x, that is equals to ln x. All right. So this is the graph of ln x, and then let's put both graphs on the same plane. Let me use a color to distinguish them. So for ln x, e to the x, I already used that. So this is e to the x. So this is e to the x. So this is e to the x. And then what about ln x? ln x looks like this. So let's use this color. So for ln x looks like this, right? There is a x-intercept, and it looks like this. So this is ln x, and that one is e to the x. They are the inverse function of each other. So e to the x is the inverse of ln x, and ln x is the inverse of e to the x. They are the inverse function of each other. All right, so that is the end of this video. If you think my instruction is clear and helpful, give me a like. Share this video in any social media for me. If you are new to the channel, please take 2 seconds to click the subscribe button down below. I highly greatly appreciate your help and support to the channel. I will see you all in the next lesson. Signing out.